Alright, now we're getting to some fun examples involving properties of exponents. Here we have negative 3 x to the fourth y to the negative 1 all being raised to the power of 2. This looks very similar to that property where we have a times b to the n, in which case it tells us to distribute the n to each factor here, a to the n times b to the n. But here we have more than just two factors inside the parentheses here. We have namely a factor of negative 3, a factor of x to the fourth, and then that factor of y to the negative 1. But there's that's not really a big deal because we can extend the property that I've written out in orange here to apply to more than just two factors. In other words, that power of 2 can distribute to all three of these factors, including the negative 3. So we're going to distribute the power to the negative 3, x to the fourth, and also y to the negative 1. And here's what that's going to look like. I would encourage you to write negative 3 in parentheses before you give it the power of 2. Likewise, write x to the fourth in parentheses, give it a power of 2, and then write y to the negative 1 in parentheses, give it a power of 2. Well, we know negative 3 squared is 9, so we can go ahead and write that as 9. That's getting multiplied to x to the 8th. And how I'm getting that is with another property of exponents, in which case we have a power to a power, so we'll multiply those out. 4 times 2 is 8, therefore we have x to the 8th. And then that's going to get multiplied to y to the power of negative 2. Again, using that one property of exponents. So there we have it. We went ahead and distributed the power to each of those three factors. But we're not finished because we have a negative exponent in here. But we know how to fix that. We'll just rewrite y to the negative 2 as 1 over y squared. Let's keep 9 times x to the 8th as is. And there is a cleaner way to write this. To start that, let's write 9 as being on top of 1 and x to the 8th as being on top of 1. Because now it looks like we're multiplying three fractions together. And anytime you multiply three fractions together, you can just go ahead and multiply all three tops and multiply all three bottoms out. And we'll get a final answer of 9x to the 8th. Oops, sorry about that. 9x to the 8th all over y squared. So that's our final answer, 9x to the 8th all over y squared. I do want to let you know that this isn't the only way to go about solving this problem. So I'd like to show you maybe something else that may have come to mind instead of my solution here. I'll go ahead and break it off. Another way that you can go about doing this is to just use the definition of an exponent. That power of 2 tells us that there should be two factors of negative 3x to the fourth y to the negative 1. So alternatively, you can write those two factors out. And then you can group off corresponding factors. So for instance, we have negative 3 times negative 3 all in the mix. We also have x to the fourth times x to the fourth going on here. And we also have y to the negative 1 times y to the negative 1. Negative 3 times itself is positive 9. X to the fourth times x to the fourth. Property of exponents tells us that we can add the 4's together. I'll write it out. And then again, that same property of exponents tells us that we can add the negative 1's together. So we get 9x to the 8th, y to the negative 2. Go ahead and rewrite y to the negative 2 as 1 over y squared. Go ahead and write 9x to the 8th all over 1. multiply across top and bottom, we have 9x to the 8th over, not sure why it keeps doing this on me. But anyway, 9x to the 8th all over y squared. And that's a different way of getting the same answer. Whichever way you like most, go with it. Otherwise, that's it for this video. I'll see you in the next one.